Hello. I am going to get back to actually doing just a little bit more work today, at least. So what we're working on at the moment is we're getting this camera more set up, and we're working on one of the parts for it, which is this dude right here. Basically, I need to enable this camera lead velocity, and we're working on getting the velocity lead working. It should be that when we actually run this, that our velocity lead looks good. And right now it's real crappy. It's real quick and, you know, just not very good. So let's fix that. So the two things that we're working on is we're doing the camera lead based on velocity, and we're also going to be doing the jump box for camera. I don't know how much I'm actually going to get done here. I'm kind of my last legs today, but we'll see what I can actually do because I still kind of feel like working, so I will. Oh no, it wants a password. Well, we're just gonna have to off-screen this. So it's having trouble checking this thing out. What? Did somebody check out my level? Let's see. Source control, check out. Okay, so sometimes it's just kind of an issue. It's this camera test built data. Alright, so yeah, it's just being a little finicky. Alright, so let's actually get back to the coding portions. So, what is this? Determine camera lead. And what we're going to need to add are all the other things. We're going to need to add the easing, and we're going to need to add all the rest. So, God, I gotta remember what the hell I was doing, like, you know, a couple hours ago. Like, a couple hours ago, I mean like 6 hours ago. Alright, so current fall velocity, we're gonna need the... We're gonna need to check all these things out. This thing is still running? Yeah, let's just force kill that. The editor's been running for a long time. We left it on when we went to go get food. Alright, so I need to check these files out. So for follow velocity, we're going to need our M follow delay start. We're going to want our bool M leading. What the have our float. It's going to be lead acceleration. Alright, so that should do that. And we're also going to need a calculate the camera lead speed. So it's going to be calculate camera lead speed. Gotta calculate that sweet lead speed, am I right? I'm right. Am I right? I don't know. I don't know what I'm doing. Cool. Alright, let us do all the calculations. So let's throw all these functions kind of together. Awesome. So what we need here is to make sure we got all the right variables. So we got camera lead offset delay, camera lead offset acceleration, and camera lead offset fall off distance. And yeah, so we have those variables. We just need to start applying them properly. So we need to do our speed should be like calculate offset move speed. So it's going to be like calculate camera lead speed. Alright, so we have already calculated all the things. Camera lead offset. I think what we need to do is we need to actually say the speed is like this. So speed is going to be calculated after we know the wanted speed. So it's going to be like, yeah, we're going to say like speed equals this camera lead speed. Then we're going to pass speed into this guy down here, and we'll just get it working. So we're going to have a delay on actually leading our camera. So again, we need to make sure we got our times and everything set up properly. And leading false. So basically what we're doing is we've got a timer until we start our actual lead. So you have to kind of want to lead the player by a little bit for a certain amount of time. And then once that time has elapsed, then we'll start accelerating towards our maximum lead speed, which will be moving the camera forward to kind of our wanted position. So our lead speed, so now is going to be this, and we're going to see like if gosh, this is a good question here. The offset move acceleration. I think we need to do like this im leading left is what it should be, because we're like leading to the left of the character or leading to the right of the character, and we don't want to flop. Alright, so it's now leading left. So it's going to be the wanted camera lead position dot y is. Alright, yeah, so wanted camera lead offset versus the current camera lead offset. So leading left is going to be if our current camera lead offset dot y. So if our camera is to the left of where we want to be, then we are going to the left. Okay. We're wanting to lead to the left. This is going to be current camera offset direction minus this offset move delay start. So okay, if the difference between our wanted camera lead offset and our current, then we need to set our follow delay start to now. So if we are now leading left does not equal m leading left, then the offset move delay start, this is going to be follow move delay start equals now. Basically reset the timer when we have any sort of flapping, so we don't immediately start moving the camera, because if we move the camera all the time, people get super sick and they hate it. So this is not direction offset delay, this is camera lead offset delay. So wanted acceleration is either positive or negative. So if we're now moving left, now leading left, then it's -1. So this should be camera offset, this should be camera lead offset acceleration. Offset move acceleration. We want lead acceleration. Otherwise, we are moving towards 0. Basically, if we've got a direction to go, let's go towards that direction. If we are not, then do it. So if the offset move acceleration is greater than 0, and we are not moving left, or offset move acceleration, this should be the lead acceleration. So if our lead acceleration is positive and we're moving to the right, then we should be doing something, otherwise speed is 0. Or if our lead acceleration is less than 0, so we're going this way and we're now leading left. So that sounds good. So it's not the offset speed, it is the camera lead speed by the offset, the lead acceleration. So leading left is going to be now leading left. The wanted camera direction, this is the wanted lead offset y minus current camera. The multiplier is going to be, alright, so basically as it gets closer, the camera offset fall off distance is 0.1. So if we're within 10% of the screen, we're going to slow down. Let's see, the camera direction offset fallout distance is 1.1 as well, so that should decently work. Let's also take a look. Yes, this is in screen space. So let's see if our lead is looking like it should. Working on the basics. So let's just keep looking. Lead acceleration is what it is. Leading left. Follow delay start. Follow delay start. Yeah. So this should be lead delay start. Is follow delay start used by other things? Now why don't we just change this name real quick? It should definitely be lead delay start. Camera lead offset delay. Need Excel, wanted Excel. 0, delta T. Just looking at stuff, making sure I don't have any copy pasta errors, which are incredibly common, especially for one such as me. Alright. And let's see it. Let's see the camera lead. So, oh yeah, that's looking really good. I like that. That's totally what we're looking for. Yeah. Not too responsive. Oh yeah. That was easy. That was easy. We're making this look easy. Let's turn on all the camera things and see how that looks. Enable dynamic zoom, enable distance offset, enable camera lead. Alright, so we got our zoom, we got our directional offset, so you can look left and right, and then when we run, we get even more, and we get that zoom out. Oh shit, I'm off the screen. Oh yeah, I'm liking this. I'm liking this a lot. Let's see if we can actually platform with this sort of camera stuff going on. Ah, I'm missing them. Well, I am missing them. Ah, I fell off. So that's one of the things that I gotta work on next is we want to have like a kind of a jump box. So if you jump, we're not just gonna immediately slipped off. And the movement is all sorts of janky at the moment. We have not tuned movement whatsoever. This is literally just the camera that we're messing with. What I'm testing here is basically if the camera like feels really awful to me, then, or if I'm missing a jump, if I feel like, man, the camera really just sabotaged the hell out of my perspective. Ah. And this is like awful movement. It's just garbage here. Ah. And you can even slide off of the frickin' stump. So I am pretty happy. Like the basic stuff's all moving properly. He's got Parkinson's bitey with his freaking jerky arms. Yeah, I like that. Zooming as well. made it. So let's implement the next section of this. So the next section of this is we need a jump box. Which basically, if this box is our camera, and we are this character right here, we want to kind of allow ourselves to move vertically between like maybe these 2 points without actually moving the camera itself. So how exactly are we going to accomplish that? Basically, so like if I move up, I'm not actually going to trigger the camera to move for a certain amount of time, like a small amount of time. We don't actually want this to be there because when we're jumping, I can kind of simulate this really shittily with turning down the global move speed of the camera. Maybe that'll help me visualize it. What exact math? Because it's not actually like let's not move or something else. It's an offset. So if we turn like the camera speed way down, you can see like, you know, Bitey can we can kind of get a little bit, maybe a little bit better jump out of him, because we can always see like what we're landing on. Just like, he looks so ridiculous, like flying past. He's like, meow. So how exactly do we want to do it? It's basically like we're adding. Yes, Karakan, I got back to work after Adam and I did our weekly planning session, and I got some food and I went shopping and all the cool things. So now we're all prepared to take on the rest of the universe. So how exactly do we want to do this? It's basically we have like we know where we want the camera to be. Like we have a place where we want Bitey to be at rest. But we kind of want to add a vector to Bitey based on the difference between his height, between his position vertically in the screen and like our maximum vertical in the screen. And we want that. It's difficult to explain. Like, basically, if this is where this is our height right here, and this is us, and we jump, so our vertical velocity all of a sudden changes. We actually want to add, you know, potentially this vector right here. So like we want to add like a 0.5 in screen space, potentially, and we want that to shrink. We want that to go back to 0 based on something. So the universe has no chance. I'm trying to think of a good mathematical way to do this, because we're not actually like just letting him move in the camera. Like, we know where Bitey's supposed to be on the screen. We're actually, instead of moving after him, we're actually actively moving the camera away, to a certain extent. So we have a vector that goes like this. So it's a maximum, it is a y, it's always a y vector straight down. And that goes to 0 based on time. So it starts small, gets big fast, and then it starts getting smaller slowly. And this should only trigger when on certain things, I guess. Or should it always trigger? We don't want it to always trigger, because like if you're running up a slope, should it just be if we jump? I don't know. Basically, Adam's posed a question for me, which is to get the camera moving so when you jump that you don't actually... The problem is when you jump and you jump too high, you can't see the platform that you wanted to land on. So basically, we don't want to move the screen. You know, we don't want to move the camera up if we don't have to. Well, why don't we just go with a naive implementation of this? And basically, we're going to have an F vector M current vertical allowance vector. So it's like vertical allowance offset. And float M vertical allowance start and bool M shortening allowance float M allowance acceleration, and then we want a wanted allowance. So wanted vertical allowance. We're also going to need a void determine camera allowance. Delta T, and calculate allowance move speed. Allowance speed. We'll just do that. So we got 0.0. Our shortening allowance should be false. Our allowance selects acceleration should be 0. And our current allowance offset and our wanted vertical allowance. Alright, now we need to add our values for our vertical allowance. Outside of the box? No, we don't ever want Bitey to go out of the screen. As far as, like, if you jumped out of the screen, then like, ugh, you know. But hey, if you tuned it to that, you'd totally be able to accomplish that. Not that I want to, but it should be possible. So, camera vertical allowance. Allowance max. So, use vertical allowance. So allowance speed, camera allowance max, camera allowance offset, or yeah, camera allowance delay, camera allowance acceleration, and camera allowance fall off distance. Oh, zoom the camera out to see Bitey and the platform? That would be a different operation than this. I mean, it's an alternative solution would be to literally just zoom the camera in and out based on something like that, right? Which would basically be it would be something like when you jump, you would take the Y position of the jump, right? And you'd want to keep that Y on the screen. So you would zoom out to, include that Y up until a certain point, and then you would then you'd like zoom in until you hit the ground or something. Then it would slowly ease back in or whatever. I'm not sure I want to do that because that's a really quick zoom. Like it requires the camera to move quickly, right? Because Bitey's gonna jump real quick, right? Like his fastest point of the jump is the beginning of it, so you would actually zoom out very quickly all at once, and I think that's a little bit jarring. So I'm gonna try this one first, and if it doesn't work, I'll think of a different plan. And I'll keep yours in the back of my head and see if that has a grain in it that I believe will help solve some of the problems. Camera allowance max 0.5. Camera allowance delay. 2.0. Camera allowance acceleration 0.5. Camera allowance fall off distance 0.1. Determine camera allowance. want to calculate the allowance speed. Okay, well, we're just going to set PIM camera allowance vector 0 vector, and then current vertical allowance offset is just going to equal M1 in vertical allowance. Alright, that should do for that. We'll implement that in just a little bit. Determine camera lead. Yeah, this needs to go up. Calculate camera lead speed. Compute final camera position. So we need to, bool vertical allowance equals true. So vertical allowance is going to equal our camera data, use a vertical allowance. And our vertical allowance, so basically it's going to be, the offset vector again is going to be like so, and it's going to be current vertical allowance offset, so this should actually be 0 for the Y. Well, whatever, maybe it's not. So offset vector, so final point of camera position, it's going to be plus equal to that. Excellent. So what we should see now is this should all compile, and it shouldn't do anything. Determine camera allowance. Camera allowance. Determinate, alright. Determine camera allowance. Determine camera allowance. Jesus Christ. All the misspellings. Just trying to get my back a little bit happier. It's like, dude, you've been sitting down for like 10 hours. What the hell is wrong with you? You should get up and do things. Like, no, I shouldn't. I shouldn't do anything. I should keep working. I should keep working on programming. Because programming is what I should do. It's my lot in life. I didn't go to 4 years of programming school to be Mr. Has proper posture. No, did I? Alright. Let us make sure that all of our settings are there, and then let's make sure that we can turn them on and off. So Standard camera. I'm gonna reset to 50,000. Camera vertical allowance is on. The allowance speed is 1, 5, 2, blah and blah. Excellent. That's exactly what we wanted it to be. Gotta be enough. No, I gotta walk downstairs. How awful is that? I've got these steep little stairs. I go into my basement. Make push-ups. That would be really funny. I should just use... I should get it so you can redeem Sparks on Adam's stream to make me do push-ups. And then Adam will be all like, "Oh man, we need to get more Sparks in here so we can make Kirk exhausted." I'd be for it. That'd be pretty funny. For like the first 20 minutes, and then I'd be like, "I hate life. I hate you. I'm done with Twitch. I'm gonna start my own life out in a cabin by myself without all you bastards. And I'm not even gonna have internet." Alright, so vertical allowance start is there. So what exactly? Let's try to get this to start with. So what exactly is this vector gonna be? Like, so it's, how the hell do we calculate this? Like, so if we're moving upward at a velocity, we need to add a large vector. Excuse me. We need to take your positive z velocity and we need to create a vector that's very large based on it in screen space. That vector cannot be larger than your current velocity. So we also don't want your smooth velocity. We need your current velocity in the axis. So this one's a little crazy, isn't it? Alright, so it's gonna be like M wanted Well, I'm not exactly sure how this is going to even work. So it's like him followed actor get movement. It's like you Dashkin movement object star movement. Excuse me. If movement does not equal null pointer, then we want to get the y velocity. So it's going to be movement get velocity. So it's going to be f vector vel. What's this? So it's going to be like vel.y. So we want like our basic vector here. Our offset vector should be so if velocity.y, it's z, is greater than 0, then our we need to get our velocity and turn it into screen space in order to actually calculate this. So basically the velocity is going to be the offset vector, so offset.z equals the camera height multiplied by the velocity.z times a -1 multiplied by delta t. And then we're going to divide by camera height? That doesn't make any sense. Is it velocity.z divided by camera height? It's probably that. So that'll take our velocity and turn it into screen space velocity. And then, yeah, that'll work there. So that should give us our offset z. So the faster we are moving up, the more we'll be looking down. Alright. So it's going to be the wanted vertical allowance. Equals the offset. I have no idea what this is going to look like. Let's see what it does. What it should do, basically, is in screen space, when we jump, the faster we're going, the more our camera should be down. So when we jump here, we should see the camera basically follow us up. So it should move. The camera should stay in the same place and then very quickly rebound into us. And we're gonna need a set, else offset equals, yeah, we'll just start off with the offset equaling the f vector 0 vector. Also, I guess it's Tuesday now. That's a thing. So let's turn off everything else. And we're going to save. And we're going to add this to the print. So it's going to be the wanted, the camera, vertical allowance, yeah, vertical offset. Just do that way. Camera vertical offset. Gotta get that sick camera motion going. Hopefully not sick, just normal. A sick camera motion would probably be bad. Whoops, wrong button. I'm seeing a whole bunch of nothing happening here. So the follow velocity is blah, the camera vertical offset is 0, the camera vertical offset is 0. Okay, so determine camera allowance should be saying if followed actor is null, if it's not null pointer velocity is get velocity, if velocity.z is greater. Offset.z is velocity.z, which is 5,000 divided by camera height, times delta t. So you've got like a 6,000 velocity divided by a camera height, which is going to be like 700. Well, it's not going to be a 0. It's negative 0.031. So that's going to be like a negative . Current allowance.c is wanted vertical allowance. Current vertical allowance.c. Speed is 0. Calculate camera lead speed. Alright, it's supposed to be calculate allowance speed. So that would be why that's not doing anything whatsoever. So it's working a little bit, but we don't want it to catch up so fast. Okay, so it's basically like if the wanted vertical allowance.z is greater than, is less than, yeah, so if the wanted vertical allowance is greater than the offset z, so it's basically like if we want to go farther down than we currently are, then we snap to that. Otherwise, the wanted vertical allowance.z is going to want to travel towards the offset z. So it's a little bit roundabout. This is actually very different logic than what we're using for the other things. It's offset z is what we're trying to move towards. With camera data, yeah. So speed should be camera data, camera allowance speed.